Okay, so this is how I solve usually these problems. So here's a pedigree, right? And this, you can tell that it's an X-linked disease because the only one affected by the disease are the males. Okay, this is a conditional probability. Now, she wants to know what's a risk of being a carrier because she wants to have babies. And she has 4 siblings. Um, her grandma uh, could have been affected, could have been a carrier, sorry, but we don't know about her mom, right? Well, she actually should have been a carrier because otherwise they would have not have inherited any disease. Okay, so let's see the cases. There are two main cases. One, actually three. One, that she is a carrier but she not transmitted it. Two, that she's not a carrier and she did not transmit it. And three, that she's a carrier and she transmitted it. Okay, so let's look at the different cases. When you do a Punnett square, you want to first of all do a Punnett square and see what the cases look like. So if she was a carrier, she must have been X affected and X not affected. So the X here was carried on and he had the disease and he had the disease. So there are different cases for her. If you do a Punnett square, you can see that her being a carrier and her dad not being a carrier, these are what their progeny could have looked like. Now she is a female, we know that as a fact, so you just want to look at these two. So her chances of inheriting are 1/2, and the chance of not inheriting is also 1/2. So let's divide them in two cases. So this is her mom given a carrier, so her mom not being a carrier. So 1/2, 1/2 chances, 1/2 chances of probability of A, 1/2 chance of probability of B. Now her mom married, or she had children with somebody who was not affected. So this is what their probability for their children were. Well, 1 to 5 would have been. So this if she was not a carrier, and this if she was, this if she was a carrier, and this if she was not a carrier. So her children each have, the boys have 1/2 chance of being a carrier, and 1/2 chance of not being a carrier. Same for the girl, 1/2 and 1/2. In the case that the mom was not a carrier, they all have 1 chance of being healthy. So here I put them in this table. So first I want to look at the condition probabilities. So first of all for the mom would be 1/2, and I put it over here. And for mother and daughter being carriers, you want to do them joint probability. So here I put in the condition for each of the children, the mom, and then when you do the joint probability, it's 1/2 times 1/2. So you have to multiply all of them. So all the brothers or the siblings and her. So 1/2 to the 6th. And this will give you a joint probability that if the mother and the daughter carries of 1/64. Okay? And this is case 1. Let's see the case in which the mother and daughter are not the same. So the mother is a carrier and the daughter is not. So if the mom is a carrier, her chances is 1/2 of being a carrier. And if she is a carrier, we've seen it through the Punnett square that the chance of her children being carriers are also 1/2. So you get here 1/2, 1/2, 1/2, 1/2, all the way to the daughter. So you want to do the joint, you multiply all them together, and you also get 1/64. Now this is where things get interesting. What if the mother and the daughter are not carriers? So the chance of the mother not being a carrier is 1/2 we've seen before. And if she is not a carrier, so probability B, her children all have probability 1 of not being carriers. So it's going to be 1, 1, 1, 1, 1, 1. So when you do the joint probability, you do 1 times 1 times 1 times 1 times 1 times 1/2 from the mom, and you can still get 1/2. And then you want to do the posterior probabilities. And the posterior probabilities are basically what's the probability of event 1 happening over all the possible probabilities. Okay, so probability of 1 was 1 over 64 over all the other probability events are added up together, and they're this, and you get 1 over 34. Probability of 2, you get exactly the same number. And the last one, it's probability of 3 over the sum of all the probabilities. You get 16 over 17.